I'm going to give a talk about JSON-LD for linked open data and knowledge graphs. First, a little bit about myself. I'm a cognitive scientist and been working for Lisp and Prolog for about 40 years, right? But recently, I'm the CEO of a company in the Bay Area called France Inc. It's a Lisp compiler company, but for the last 12, 13 years, we've been totally focused on a graph database called Allegro Graph, right? It's a graph database like most others, except we're a semantic graph database. So I'm first going to talk about the world of semantics, RDFs and graphs. And a quick question, who works here with RDF in this one? Right? Who works here with JSON-LD? No one. Okay, great. At least a fresh audience. So I'm going to talk about semantics, then I'll talk about the world of JSON and documents. And then I'll talk about the intersection of JSON and semantics called JSON-LD. And then I'll talk a little bit about whether you want to store these documents in a document store, in a semantic graph database, and what the advantages and disadvantages are. But a lot of my talk will be just mostly about open data, right, and open source data, and what you can do with it. So first, let's talk about the world of semantics in RDF. You might be inventing kind of the HTTP, HTML, right? And then after a while, he kind of complained that, okay, now we have this wonderful internet. And please remember, this is 1994. Yeah, only humans can read the content on the web. Sorry, it says context. I mean content. But computers can't, right? So what we really need is a metadata language that gives meaning to the objects on the web. You have so that a computer, for example, could say your resume on the web and understands the structure of the resume, or you have metadata for a recipe and will understand the recipe. And so he had an idea that almost every type of object on the web should be readable by computers, right? And so he thought about, okay, how am I going to do that? And he came up with this language called RDF. Now, RDF is a very, very simple language, and it amazes me every day that people complain how complicated it is. And at the end of the talk, I will ask you guys, do you still think it's very complicated? Or maybe you never thought it was complicated, or maybe you never even thought about it, right? But okay, so what is RDF? At the core is this idea that every object in the universe needs to have a unique identifier, yes, and the identifier should be an IRI, right? Because if you don't give the same name, the same thing, then it's really hard to build large integrated enterprise IT systems or almost anything, right? So the first principle of RDF is give every unique thing a unique name. The second thing is that you can describe almost anything in the world as triples, and I'll give some examples later. But so you can say Jans is a man. Very simple, a triple, right? And you literally can describe almost anything you can think of using these simple triples. And then finally, the third part of the semantics is that data should be self-describing. For every IRI in your triples, you should be able to go to a place that actually explains what the thing is, what the type is, or if it's an attribute of a thing, what that attribute means in this particular context of this type, right? And we call these things schemas, or we call them ontologies. Anyone here ever worked with ontologies? Okay, one, and you should be. All right. So now let's look at some triples, right? So I want to describe that there's a person born in 1958 with the first name Jans, last name Aasman, who lives in a place with the name Moraga that is part of the state California, right, in the population of these places. Well, the way computers really like to get these triples in is in a format called n triples, right? So you have a person 1, so it's got a unique URI. Person 1 has a first name Jans, right? So now that's one triple. These things, the subject of the triple is always a IRI, although it can also be a kind of what we call a blank note. The predicate is always an IRI, and then the third part can be any XSD data type that you want to have. Now, for a human being, looking at these triples is completely overwhelming. So we have another format that's even example code, right? So here we have the same information that we just saw here, right? And I can literally show this to any person on the street, right? I said, okay, what does that mean? And the person will instantly tell you that there's a person, that is a thing with it, that is a person, right? Anyway, you get my point. The only thing that might be a little bit surprising is the here, because we use RDF type so very often as to give a type to a particular instance of a thing, that we came up with a shorthand called right? So now we can say person one is a person. All right, so now we have this. And then if I would make it a little bit more complicated, right? So I could say there's a person that lives in 2 places, is married to Sophia, Jans pays taxes in California, in the USA, and they have a son in Stockton, New Jersey, right? And again, if I give you a minute, then you probably would be able to figure that out. But what you probably don't realize is there's already a kind of a complex graph in there. I have no idea if that's readable from this distance. So this is a tool called Graph, that we have a visual interface to our RDF graph database that we sell, right? But this is the visual interface on top that allows you to look at all kinds of different ways to graphs. So here you see the names of the predicates, the types of the objects in the graph. Now this is hard to read. You can render it in many different ways. One of them is what we call the tree view, where you try to use the shortest distance to lay out things on the screen. But anyway, here's a graph, right? And now I want to do a query. So this RDF also has a query language called Sparkle. It looks very much like a SQL. You'll see some real Sparkle code in a second, but what we do is we have like a visual query language where you can say, well, there's a person, first name, last name, and everything with a question mark is a variable, right? This person pays taxes in California, and basically it expresses what you see here. And if I push this button here, then this is the underlying query that I don't have to write code for, but I just, well, here you see there's a place 1, question mark, so this is variable, is part of a state, right? And there's a place 2, part of the same state here, and that person 1 pays taxes to state 1, and he lives in these 2 different places, and there's the last name and the first name, right? You guys all know your SQL, right? So is there anyone that would have trouble with reading a query like this? Would take probably a little bit, but I give a lot of tutorials, and once I get SQL people, then it's very, very easy to explain. It takes a little click in your head, and then you got it, right? Okay, so this is the query language for RDF. And then you might have heard, I already talked about ontologies. People also use ontologies to A, describe an object in great detail, and B, to allow for reasoning over your data, over RDF, right? So this is a tiny one. Here am I saying that a person is, this symbol person is a class, and a person is actually a subclass of mammals, right? And the mammal is also a class of things. And I could say, I can describe predicates. I can say has parents is an owl object property. And then I can add something to start reasoning. I can say, well, has child is the inverse of has parents. So in my database, I have that Hans has parents, Sophia and Jans, right? But by telling the system that has child is the inverse of has parents, oh, well, I can start reasoning. First, let's do the mammal thing, yeah? Because I said that a person is a subclass of mammal, right? I can now ask the database, is Jans a mammal? And if I ask this question, I get, yes, Jans Aasman is a mammal, right? So that is one way, simple, very simple reasoning. Or does Jans have children, right? I mean, I can say, is the person 1 has children, person 2? Well, in the database, there's literally no triple that says person 1, or Jans has triple Hans, but because of this ontology definition, the system will automatically infer that I have children, right? So this is the tiniest, smallest RDF tutorial that I can give, right? But I hope you get it now, right? All fairly common sense. Okay, now if you want to read about it, the biggest standard on W3C is about semantics. There's so many different standards. There's the RDF standard for the triples, there's OWL, that kind of does the definition of things and reasoning. There's the Sparkle query language. Then you get an RDFA, which is a micro format for objects on the web. You get JSON-LD, I'm going to talk about that later, which is just a JSON serialization of triples. SCOS is for taxonomies. Anyone here working on taxonomies? Okay, so you know what a taxonomy is, right? It's a tree of words that describe the important words in a particular domain, right? So you, I think I'll get to that in a minute. Anyway, many more standards, but the W3C has been working for 20 years now on the standards for RDF and every derived technology. So now where do people use RDF? Well, the first place is nearly every Fortune 500 company is now building SCOS taxonomies, and I'll go into detail a little bit later. It's used for the link to open data that I promised to talk about. It's both for public data and for enterprise data, and so I'll talk about it some more. And then nearly every Fortune 500 company is right now building knowledge graphs. So in your companies people are building knowledge graphs? Not? Okay, so another fresh area to talk about. Good, so let's talk about RDF taxonomies and ontologies. So as I just said, all these companies are now building taxonomies, and all of them are RDF based. And basically, for example, in healthcare, right, there's a taxonomy that describes every concept that is, for hospital, taxonomies for hospital. People have built a complete massive system of words that are important in the context of a hospital. So every medical term will be in there, right? But there's always hierarchies between words. So basically you always think of a hierarchy of words in a particular domain. And I said words, but actually I'm wrong. We talk about concepts, because a concept is also just a IRI, and then you can have a pref label, like lung cancer, right? An alt label, all the variations of how people talk about a particular lung cancer, right? But lung cancer itself is like a subtype of cancer in general, right? But also a subtype of lung diseases, right? And so taxonomies can be very complex trees and graphs of how a bunch of words hang together. And maybe you've heard of WordNet, right, created by Princeton, that describe all the words in the English language. It's kind of an overall general taxonomy of important words. Anyway, so people build the taxonomies, and they do it for many different reasons, yeah, to improve search over documents, right? Because if you have chosen, say, you have a concept for lung cancer with the Latin terms and maybe terms in many different, with a pref label, so you have a concept for lung cancer, right? So that's just an IRI. It will say that lung cancer has pref label lung cancer. It will have alternative terms. And so now what I can do when I can search for any synonym of the word lung cancer, right? But modern search system will still find it because they linked all the meanings of lung cancer together, right? You can improve your NLP process, basically the same thing. Some of you guys must have been doing entity extraction from text, right? Where you try to find all the important words out of a text, but again, you don't, if there's a big document and there's 5 ways that people refer to lung cancer, you really only want to have that concept, right? You don't care how the text refers to it, you just want to know what the ultimate concept was that was in the text. So people use it for that. People use it to harmonize documents, databases, processes, and then we use it to build knowledge graphs. And knowledge graphs are basically applications of graph databases where you try to collect everything you want to know about a particular entity that you're interested in and the relationship of that entity to everything else in your company, right? So those are knowledge graphs, and I'll talk about it later a little bit more. Now most taxonomies and ontologies, sorry, I don't know what I was. I meant to be, So within companies, people make these taxonomies and ontologies, but also in a particular enterprise domain or field, people need ontologies, like in healthcare, right? Or in a bank or pharmaceutical industry. So there's actually big efforts going on cross-enterprise where people say, okay, building a taxonomy of all the important words is something that I don't get any competitive benefit from. Let's just all work together so we can share data, right? And so there's a lot of efforts going on right now in all kinds of domains to create domain taxonomy. So a big one is in life sciences. For example, at Stanford, there's this website called BioPortal, and they collected several thousand life science and hospital taxonomies and ontologies, right? So if you want to know something about a particular lung cancer, you look it up on this website, and you get all the taxonomies where that concept is important, right? This is all open source, by the way. And then about more than 20 banks worked together for the last 10 years to come up with a taxonomy and an ontology of all the important words in the world and concepts in the world of banking, yeah, so that it's easier. By the way, this was mandated by the government, so that for the government, it's later easier to compare banks on various measures, right? Because if everyone uses different words and concepts, it's very hard to compare. I hope that makes sense, right? And so engineers do it, gas and oil has some, yeah, lots of examples. Okay, so that is about taxonomies, and they're very, very important, because without a taxonomy you can't build knowledge graphs or do a lot of things. The other thing is linked open data, and there's basically what it is: you take public data, all those, and you make it available as these triples, as RDF, right? Now Europe started with this like 10 years before the US started promoting it, so they're spending a lot of money in these big European research projects, and they now, for example, force, if you want to get a research grant in Europe, right, you have to take 5 to 10% of the funds you get, so that after the project is done, you describe all the data sets, all the metadata, so you put your data set somewhere and you put the metadata that describes exactly what's in these data set. And they use for that RDF technology, right? Because usually people do research, they pick the little thing that gives them a great publication, and after a while all the other stuff is gone, right? But so many uses, and people could use the data again for their own experiment, right? To get more insights. So anyway, that is already mandated in the EU, that you use RDF to describe the data. And then in 2021, the National Science Foundation and the White House started a big project to kind of look at all the data in the government that is publicly available and do something useful with it in what they call these knowledge graphs that I just talked about. And again, 99% of these knowledge graphs will be RDF related. Any questions about this? And then there's also companies that then just on a commercial basis make that available. But then, for example, in enterprises where you take enterprise data and you use the same principles that you use for public data, except you use it within the enterprise. It's a company called Dataworld, right? That's creating all kinds of technologies to take your data lakes, right, and make all the data available as RDF. But they also have as a mission to take all the public information in the world available in their data centers as public data that you can then work with later. Interesting company. Anyway, but all this linked open data stuff started how long ago? Maybe 20 years ago, right? Where people took these public data sets and made them available. I hope, can anyone here read the word DBpedia there? Yeah. So DBpedia is basically all the info boxes in a Wikipedia page made available as triples, right? So this is an enormous amount of triples by now. It's like, I don't know, 15 billion triples, right? But literally everything in the Wikipedia, you now can just do a Sparkle query to find a concept or article in all the relationships to other articles. And that's why it's in the middle, because this is probably the most important one. But then there's some other ones. Here is linked clinical trials. This is 350,000 clinical trials made available as triples, and I'm going to do a little demo. I'll show you something about that. Something like geonames. Maybe you have heard of that. It's a database of 7 million places on Earth with all kinds of metadata. And it's also available as an RDF tuple store. And there's a little story here. I don't even know half of them, though I probably know half of them, right? Very interesting data sets that you can download from somewhere and then play with and do useful things with. Now this was the linked open data cloud in 2009. This is the one in 2022. It's become absolutely, completely, totally unreadable. So now you still can go to this cloud, but then you'll go to the top here and you say, okay, I want government. And this is not interactive, but you would click on government and then you see a much more reduced cloud, right? That is specific to the government, right? So it's kind of exploded a number of interesting data sets that you can do something with. And it's very active in the in Europe, but I'm beginning to see the same thing in the United States. Okay, so you have all that linked data, right? So now what can you do with it? You have that open data. Here's a thing that I usually demo. I'm not going to demo it today. I'm just going to talk about it. But for example, you want to know what was the median income of the area where Barack Obama was born, right? Well, when you do a Sparkle query to do that, then you first say, well, in the DBpedia, find the birthplace of Barack Obama, and then find the GeoNames ID of that birthplace, right? So now I have the GeoNames ID, right, where Barack Obama was born. Then you go to the GeoNames database, and you find all the GeoName IDs within 10 miles of that thing, using some geospatial capabilities that almost every semantic graph database has. And then you have now a bunch of geonames, and now you go to the census database that's also available as a triple file, and then you find the median income, right? Does that make sense? And so you can do a query, and I'm not going to explain that even today, but this is the query. What I just did in English, right, is in Sparkle, and I find the 4 places within 10 miles of where Barack Obama was born, right? But just think about it. Three groups of people worked on their data set, right, in a completely independent places, but because they really believed in the principle of giving a unique name to unique things, right, you kind of can automatically integrate these data sets and do very interesting things with them, right? I always make the joke that to talk about the importance of a unique name for a unique thing is that in our semantic community, well, let me start the other way around. If you ask a developer, in a company to ask a new application that needs a relational database, right? That person that makes that application, there's not a single neuron in that person's head that thinks about how's my database going to work with every other database in my company, right? Doesn't happen, ever, never, right? In our community, when we make a data set, the only thing we think about is, okay, my data only becomes more important if I can share it with everyone, right? And I can link it with everyone. Otherwise, I make a very pathetic little silo thingy here, right? So it's a huge, almost cultural difference between the people in this world of regular modeling and the semantic community. The semantic community, data sharing is the most important thing, right? Because that makes your data way more useful than if it's only for that one application that you're trying to solve. Okay, so now I talked about taxonomies, I talked about linked open data. Now let's talk about knowledge graphs. So again, this is a fresh audience with respect to knowledge graphs, right? You haven't done much with them, I'm guessing. So, you know that what Gartner does, they say what's most important, but basically they do that by looking at what's happening in the world, right? So what they noticed is that in their hype cycle that hey, knowledge graphs are important, right? That happened in 2018, and before you knew it, right, in 2019 it's here, and actually in the latest version that I couldn't find, it's already over the top, right? So many people are doing it that it's, for Gartner it's become boring, right? I mean, you just make knowledge graphs. Now why do people make knowledge graphs? Well, I'm sorry, not. So a lot of companies are doing it. This is for the conference, the last conference before we had the lockdown, right? I was there and I got this overview of the little conference that we went to, and what you see here is all the big companies are literally building their knowledge graph. There's Goldman Sachs, Capital One, Wells Fargo, there's Google, there's AstraZeneca, Amazon, Accenture. Literally everyone is building knowledge graphs, right? Where knowledge graphs are, again, this thing where you have entities that you're interested in, and you gather all the knowledge you can find about these entities, and you add them to that entity. And then, of course, you link it to other entities, right? Here's some commercial slides that I like to show. Now, people always build knowledge graph for almost one reason, and that is to get rid of silos, right? I mean, in every enterprise, some of you work in big enterprises, you literally have tens of thousands of databases, right? And none of them can talk to each other unless you spend a lot of money to make them talk to each other. And then data science, everyone wants to do data science nowadays, but data scientists are expensive and waste 90% of their time on data engineering, right? Getting the data clean and preparing it, right? And then most solutions, most ETL solutions, data lake things, master data management, they only make it worse. So that's why people believe that knowledge graphs are a solution to removing silos, but also to make knowledge graphs can make artificial intelligence way more intelligent, because if you do, you say, some people are data scientists here, right? Some of them. You get your tables, you clean up your data, so now you do some interesting data science work on the tables that you got, and now you learned something, right? But what do you with the stuff that you learned? You put it in a report, you send it in an email, and said, oh great, I found a new prediction, right? Maybe you made even a pipeline, but it's only a very isolated, siloed insight. With knowledge graphs, what you do is when you learn, you actually say, oh, I learned something about this patient. Then you put what you learned back in the knowledge graph. So now you enrich your knowledge graph, say, about patients with things you learned in your machine learning. Does that make sense? So by taking the output of your machine learning and put it back in the system where it came from, you create learning systems. So we're working on that. And the market is growing fast. At least, well, I hope it's good for us that it's going so fast, in the predictions at least, right? But even more important is when a lot of people, when they talk about knowledge graph, there's a new word that comes up. It's called data fabric. Are you guys working on, or familiar with data fabrics? Basically, think of it as a mature version of your IT infrastructure, sorry, where, how do I say that? Where you make sure that all the data that is all over the place is cataloged, right? So to begin with, you catalog every database that you have, all the tables and columns, but also the metadata, like what applications are using it, from what application it's getting data, what are the people that are maintaining it, what business line, what is the purpose of this, and then how does it link to my enterprise ontology of all the important concepts in my enterprise, right? So you kind of get a maturity level on top of what you already have. So it doesn't change in your IT infrastructure, but it adds a little bit knowledge and intelligence to what you have. That's what they call data fabrics. And knowledge graphs are an important component. And let me just go here. So this is a slide from Gartner. Knowledge graphs are the key to data fabrics. And basically, knowledge graphs can bridge all data and metadata silos for seamless data integration and management. And they make your systems way more intelligent by integrating rule-based reasoning and machine learning in one data infrastructure. Okay, some commercial slides. Now go back. So an example of a knowledge graph, and I can't go too much in detail. And how much time do I have? 30 minutes. Oh, wow, doing well. So one example of a knowledge graph is something we built for a long COVID researcher, right? So you know, long COVID is a really, really big problem, and people are starting to research it. But in order to study that, you need to look at the many different information types. So if you want to know about, say you want to say something about the phenomenon of long COVID, you really want to look at all the clinical trials that have been done, right? So we took the open source data, actually from the FDA, so the clinical trial data. You have to sign some kind of agreement, but literally everyone can get that data, right? So they just want to know who's using the data. And then you turn it into triples, and there's all kinds of variations that you can download, or you can make it yourself. Then there is the PubMed, right? So every day there's 2,000 new medical articles. No human being can ever read it again. I mean, 200 years ago, you probably still had a chance to read enough of it, but now it's impossible. And so we have this system called PubMed, right? Abstracts in the article itself. And some people made a selection that was all COVID related. They call it Course 19, and it's a massive collection of documents that have something to do with COVID. Then we have the FARS database, which is the adverse vaccine reactions for all the different COVID shots that you could get, right? And then we have medical records, but for our demo purposes, we're using a system, open source system from MIT called Synthia, where you can generate patient data that's actually based on a lot of machine learning on real people. But of course, for the real work that we do, we have actual patient data, but for an open source knowledge graph that we make available, we use synthetic data. Anyway, so you have all these data sets, but all these data sets use slightly different words, right? So we also have a thing called UMLS, which is published by the National Library of Medicine, what is it? And by NIH, right? And it's a massive collection of life science taxonomies. And again, many different research groups have turned that data into an RDF taxonomy. So that's for us the thing in the middle. And then we use natural language processing and basically just concept matching to take the important words in clinical trials and harmonize them. We do analytics of the data in PubMed, all the text, and take the important concepts out. We harmonize the side effects in FARS, right? And then we have the electronic medical records. And now suddenly we can do research that spans all these different data sets, right? And all open source except the medical records. And so here, and I apologize, it's probably too small, right? I came in this morning here to look at the room, and I saw that this thing was way too small, so I blew up every slide I had, but I didn't do this one. Okay, so let me just explain what you see here. So this is a picture of an object from each of these 4 data sets. So we have a medical record, so there's a person, Rodi, that is from Lewiston, Maine, non-Hispanic, female, is on some Aasman self-management program. And she had an encounter, yeah, that is paid for by Blue Cross, and she has acute viral pharyngitis, right? So this is a concept, a name, which is then linked to the ICD-10 name, which is the billing code that hospitals send around between hospitals and insurance companies. Anyway, this thing is then related to the UMLS I just talked about, right? So this looks the same name, except this one is in SNOMED in the Metathesaurus, a taxonomy system. And this thing is a more specialized version of an acute upper respiratory infection, which is has another manifestation, which is the common cold, right? But then anyway, what you see here is some terms from the UMLS, and then what you see here is the clinical trials. And clinical trials, here you see 2 clinical trials that talk about pain and sore throat and pharyngitis, and you see how that links up to the UMLS that you saw here. Then you see here 2 papers from the course that link information from these things to hypersensitivity in the sore throat, and then you see here VARS. Now, right, this goes way too fast, but for researchers this is fantastic, right? They can now take information from all these different data sources and use one simple query language, right, to start doing their analytics. And any questions about this? Does it intuitively make sense what I'm showing you here? All right, that's good enough. So now on to JSON-LD, right? So knowledge graphs are getting popular very fast, but developers are really a little bit scared to learn the W3C semantic stack. They think it's hard. I think it's bogus, but a lot of people say, oh no, I'm not going to learn all that. I just want to stay with JSON, right? So how do you make it as easy as working with MongoDB to add data to a knowledge graph, to retrieve data from a knowledge graph, and to validate the data in a knowledge graph, right? How do you do that? Well, basically, you give them what they want, right, which is JSON, but then a little bit added, and we call it JSON-LD, right? So everyone here works for JSON, right? So JSON-LD is 100% the same as JSON. It's 100% syntactic JSON, except you do two things. Did I describe it? Okay, let me do a little bit later this, right? So you guys all know about JSON, the lingua franca for messaging and data in chase, used for configuration, it's used in document and key value stores. JSON is a very simple standard, easy to read and parse by humans and machine, easy to store in document stores, and easy to program. I'm still in awe how beautiful JSON works together with Python dictionaries, for example, right? It's just really a brilliant synergy between the two. But now, you get it, but JSON, you sometimes run into trouble, right? So, for example, in the hospital that we work with, they have more than 1,000 different JSON types that they stream between various applications and the knowledge graphs, usually via Kafka, but other systems, right? So you've got all these types, and most of these JSON objects need to be persisted, right? But you don't want to make it, you don't want to put it in all these several silos, right? You need to put it in a data lake that you can do something with later. But the problem right now is if you look at any random JSON object, you literally have to go to the code to figure out, okay, how do I deal with this particular data type, right? If you make something with 5 different JSON objects, it doesn't matter. If you have more than 1,000, you're in trouble, right? And then the other problem with JSON is, in the hospital, you have a JSON object for the patient, and then you have encounters, which are objects, which have diagnostics, which are objects, which have links to maybe a provider, maybe a link to the taxonomy, right? So how do you make the choice as a developer whether a patient is this massive big structure, right, a nested structure, or whether it's composed of smaller ones? But JSON doesn't really have a standard for pointing from one object to the other, right? So what you really want from JSON is to have semantics, right? And what I mean by that is that every JSON object that you think is important needs an identity that other objects can point to, right? So you want, that's why, and the only very simple thing you have to do, by the way, is you just take your JSON object and you use as an attribute @ID, right? Which is a JSON-LD attribute, 100% valid JSON, and you give it an IRI. And because you could have a default namespace, right? So it still can be a very simple name. But it's important. You give every JSON object a unique identifier, more readable than the Mongo identifier, right? I mean, just a readable, most of the time, a readable identifier. And you need a type, right? And the type is also @type, right? But the important thing is that each type then has somewhere else an RDF description or a JSON-LD description that says, okay, so what are you trying to do with this type? Or what are the attributes and what are the data types for each attribute? What are the links to other types of objects? And maybe even more metadata like, okay, so on what version are we right now? How does it link to the processes? And how does it link to the apps? And what apps are using it? Right, so all the relevant metadata is in that ontology that describes that particular type, right? And then one more thing that you could add to this JSON-LD object is what they call a context, which is actually a pointer to the ontology that describes for this particular type, right? But that context can be the same for almost every object in your hospital. Okay, and then you want a validation language. So JSON-LD is just kind of a schema for JSON. It adds semantics, and it's designed to link objects together, right? And it enables you to do joins and graph search in document stores. And if you want to play with it, you can go to JSONLD.org, And there's a playground, and you can choose examples like a person, an event, a place, a product, a recipe, a library, an activity. And what you see here, I mean, can you guys even read it? Sorry. This is the context, which in this case points to schema.org. Schema.org is something that Google and others have funded, right? And it's a massive, massive ontology of e-commerce products, right? Then you have you say that the type is a person, and the identity of this object is person 1. This is a little bit, name is Jane Doe, and actually when you serialize the JSON object, you get the triples here, right? But in most JSON-LD, the way we do it, we also store the blob itself, right? So otherwise you're way slower than MongoDB to get the objects back if you first have to pull it all together again. So we store it as a blob and as individual triples. And JSON-LD is now everywhere. So Google now recommends it as the most important way you can mark up products on a web page, right? I mean, it's their preferred language now. So if you take Mattey Oil, right? You look at the source, and what you see somewhere in there is JSON-LD, and you see then this whole object stuck in your page. And then just to show the difference between meaning and no meaning, if I would take out all the JSON-LD things, I would get a very regular, nice to read JSON object, except the computer doesn't know how to interpret all these attributes, right? But if you add the fact that it's from schema.org and this is of type product, and there's also an aggregate rating linked to it, now Google can read this and they know what it means and they can do interesting things with it, right? And I already talked about it, so if you want to look at schema.org, there's a whole website just to look at the ontology of every product and thing you can have on the web. And then I have a little demo of what you can do it. So our database, and other databases too, by the way, store JSON-LD, right? So you can use it as a document store, but you can also look at it as a graph and do very, very complex graph analytics or complicated joins on your data. Anyone using MongoDB here? No. Okay, so let's see if I can get it to work here. So if you want to work with it, then here's a Jupyter Notebook that we make available. So you can find it on our website if you just want to play with JSON-LD and add objects to the database. And so you could make a database, a new database, and then 0 objects in it. And here's some objects from the JSON Playground that you can play with. And here you see that they are represented as as dictionaries in Python. But let's just go to the main. Let me go here to the main thing. Let's open. Actually, no, I want to do a demo, and then I'm going to do this. How many more minutes do I have? Yeah. So I want to show you a little bit about how you can read JSON-LD and represent it as a graph, right? And still have JSON-LD. So here, what I've taken is a data set that's openly available. It was published by CrunchBase in 2014, I believe. It was a while back. And I use it for demo purposes. And basically, it's about all the startups that got a funding event. It's also about all the VCs and big buyers in the United States, right? And you can get the data available as JSON-LD or pure RDF. And so, for example, we want to look at MongoDB, and here's MongoDB. Right, and I can look at that and let's see. And so MongoDB had various rounds of investments, right? So let's see who invested in this. Oh, here. I'll do this. Oh, sorry, now I have to do it. So here. So here we see, and let's look at it over time, right? So here, so what happened is, at some point in time, Union Square Ventures put $1.5 million in MongoDB, and then after a while, Union Square and Flybridge put a little bit more money in, and then Sequoia Capital got involved, and then let's see, they did a follow-up round. Then Intel Capital and InQtel got interested, and before you knew it, you get who was it? Salesforce putting in $150 million, right? So this is the first part, and I can actually look at MongoDB here, and you see here the JSON-LD object, but you also see that the whole thing is published as triples. For example, what was the category for this thing? In what city was it done? By the way, I talked about RDF. I can push a button here, and you see all the underlying URIs, the IRIs, right, for these predicates and for the values. But I usually like to look at this way. Or I could look at a particular venture fund, right? And I can see all the investors, the investee, how much money, when it happened, etc. And so this is MongoDB, and of course, at some point we also had CardSpace, right? CardSpace, which was a competitor, right? We can look at who put money in them. And the thing I always find interesting is, well, let me first look at these. Oh, okay, well, that's fine. So here are the people that put money in CardSpace. And I always find it interesting to see how two groups of investors both are trying to push a document store, right? So first you got an investment there, more investment, and then Northbit Ventures and the others said, hey, we need to invest in a store too. And they got more money, and then they got more money. And so you can see how investors were fighting against each other, right, to be the first to get the biggest store. And so what I'm interested in is, or what I found interesting is you look at this and you see that if you're an investor in CardSpace, then you won't never put money in MongoDB, right? And vice versa. I mean, why would you do that? You would bet against yourself. But still, these people work with each other, right? So I still can say, hey, was there any relationship between, do they ever invest in something together, right? And then you see, oh yeah, well, they have other things that they work together, right? So Northbridge Venture will work with InQtel, for example. Here they probably had, let's see who they invested in. QD Fission, okay, and what do? There's a category, nanotechnology and organic semiconductors and video, but not database stuff, right? So what you now see is we started out with a bunch of JSON-LD objects that I put in the database, right? And I have this beautiful graph. And I could do a query where I say, so what are the things that people invest in? No, so I have venture capitalists here that invest in CardSpace, venture capitalists there that invest in MongoDB. Sometimes they do it together, but what are the things that they then together invest in? What kind of categories, right? Say you want to do that as a query. Well, then you could just ask, let's say, let's take these guys here, InQtel, this, and this, and this, and this, and this, right? So this is a trace that I have in my graph, right, that I saw here. And, oh, no, I forgot one thing. I also wanted to know what the category was. Okay, now I can copy it here. And now all I want to do is do a query where I figure out what are the things you're invested in. And here, I would do this. I turn these things into variable nodes, so I don't have to write any code. I just look at the graph that I want to use as a query, and here, let's say, convert a variable node, new node variable. Let's make it a category, although it can be any word, right? And then if I run the query, what you see is this. It writes the Sparkle query and you get these results, but you probably want to do a little bit of aggregation. I didn't want to write that while I was doing this. Let's see here. So this is the same query, but with a little bit of aggregation. Select category and count category as count, right? And so they invest together enterprise software, mobile, analytics, finance, advertising, blah, blah, right? So this is a complex query that you wouldn't do in MongoDB, or you would write a whole, say a Python program or whatever program, right, to do the complex joins. And so that's why I wanted to show you this demo, but maybe, because you guys believe me, right, that you can do this in Python, etc. So let's have a discussion what you guys think of this, why you think it's not useful for the things you do, or maybe the stuff that you think you can use this for. Well, it depends on how deep you go, right? We have a recent test where we load about 17 billion triples from all of Wikidata data. There's a researcher that makes a query set available with 850 queries, and 90% of the queries can be done within 200 milliseconds, right? But I can write a simple cross-product query, and it takes very long to get back, right? So it depends totally on the nature of the query that you have, and whether the database is warm, and whether you have enough memory. And graph databases are a little bit more memory intensive than the other databases because there's so much random hopping around if you do graph queries. All right. Other questions?
I'm trying to build a Slack AI chatbot, QA answer chatbot. I'm plugging to OpenAI GPT-3 for topic extraction. I got 5 years worth of Slack archive, which I can export to JSON. Right now I've been loading into Neo4j, but I found you have to close database. This is the first time I heard about and I'm trying to enrich that with LinkedIn professional graphs. So I got over 1,000 people with their subject expertise, previous companies, which I can map to ontology of subject knowledge. I want to map that to a GPT-3 extraction of their 5-year work history of conversations, questions and answers, formal knowledge.
You're going to train it on those Slack articles. You want to train GPT-3 on those Slack articles.
I'm not training. Right now I'm just using GPT-3 to do topic extraction.
Okay. Well, yeah. It seems right now everyone is getting into that, right? We're doing a lot of work with it too.
So is this something that Allegro DB is more helpful in doing this Slack archive to LinkedIn join, if you will, than Neo4j?
Well, so in your case, I really would build a taxonomy of, for example, all the skills that people have, right? And there are skills taxonomies that you probably can find in RDF, but as soon as things get, and once you have a taxonomy, right, you can use the taxonomy for entity extraction. If you don't use a taxonomy, you basically get a bag of words, right, without much structure, no tools to help you with that. If you have a taxonomy, you have a structured set of concepts with their synonyms or what have you, right, to analyze. LinkedIn, by the way, I know the people at LinkedIn pretty good. They have taxonomies, right, of your skill and type of work that people do and type of company and all of that. And they have their own new graph database that they're thinking of making open source called Liquid. Right, it's also an RDF-based triple store, but they're deep into RDF too for this.
Yeah, my Slack group is technical. They're CTOs and CIOs. So yeah, I'm looking for a pre-built taxonomy. CRM. These are all HubSpot, Salesforce. What's the best CMS tool? Whether it's WordPress or map that to domain subject experts and Q&A answers they've answered in my group for the last 5 years.
So we are doing a very fun project in natural language understanding, where we use GPT-3 to actually create triples directly out of text that kind of reflect the underlying meaning, right? Now GPT-3 is both smart and super dumb, right? They don't really realize. But we're using it to create rules, to analyze text, to extract parts that we then further process. And now because the problem with GPT-3 is, right, it knows statistically how people proceed a sentences. Then they have another layer on top to make sure that it's grammatical and syntactical, but the pragmatics is missing of the underlying real world model. We're trying to use GPT-3 to help us give us clues so we can then ourselves build up the underlying real world model, right, or domain model that consists for us out of triples, right? And now you can do, I didn't prepare it, but otherwise I could show you how far we've gotten with that, right, to do natural language understanding. So maybe you should contact us here.
It's fascinating with AI.
Yes, it's really.
I'm on the wait list for Dolly. I want my chatbot to answer in a picture.
I'm on the wait list too, right? All right, any other questions? Yeah?
Can you talk a bit about how, the company's expertise in this and Prolog relates to this graph database?
How our company's expertise?
In this and Prolog relates to the entire graph database.
That's a very good question. To begin with, I built in 2008 the first version of a triple store. We already had a Prolog compiler, right? And so you can just map Prolog directly on top of triples, right? It's just like the underlying Prolog database can be a triple store. So that was amazing. But the whole point of a Lisp is that a program is data itself that you can manipulate, right? And that again is extremely Lispy in this RDF. Layers of layers of layers of abstraction. So I could talk endlessly about that part, but a great question. All right. Oh, sorry.
Underneath, are you starting to handle like shape expressions using Shack or anything?
We use Shackle.
Shackle?
Yeah. I didn't know how much. Well, I knew how much time in it, but I thought I would never get there. But in the demo that I have, we actually literally have these up. I can show you here. We do JSON-LD. So here's the Shackle context that you add to an object. All the important parts of Shackle declarations. But let's not do that here. Okay, here. Here is a Shackle, a JSON-LD expression, which basically validates a funding round, right? So we use JSON-LD to specify to your answer to the lispiness of this, right? So we use JSON-LD to validate JSON-LD. So we say that the ID of this Shackle shape is a funding round shape, the type it's a node shape, and the class that we're trying to validate with this shape is a funding round that I just showed you, right? And then it says that if you have a funding event, you can have only one. It needs to have an investee, right? Exactly one. But you can have multiple investors, and then just as a dumb demo, I said the minimum number of an investment needs to be needs to be $10,000, right? Which is stupid, but I mean, just as an example. And then I do, in my demo that I'm not going to do right now, I make a little database of funding rounds, and then I delete an investee, or I delete an investor, or I change the has raised amount to under 10,000, right? And I turn a number into an integer. And then you just say, okay, validate, and it will find you all the objects that violate those things. So it's a built-in validation system. Yeah?
Speak why you chose Shackle over Shackle. Why do you prefer Shackle over Shackle?
because as a
Is this one that we have that are over up here and we're going to do
as a company, you first try to deny that they want a new feature from you, right? And at some point you can't deny it anymore. Then you try to find someone to finance it. And so we finally had a customer said, no, I really want shackle, right, for allograph. And so that's why we did it. And because we had to see the commercial value, right? But now everyone has it as a checklist, shackle, shackle, shackle. And no one asks about shacks. So.
Would you be interested in participating in an IEEE standard for shacks?
No, there's too many. I mean, there's so many standards that. We're right now in the middle of a thing called RDF star. We're in the middle of RDF star, where you can use metadata statements about other triples, right? So that is. Yeah.
Inside baseball war.
All right. Okay. Well, thanks very much for your attention then.